Hi, welcome back to our channel and back to the tutorial for machine learning. Today we're going to continue the session called supervised learning algorithms. There are variety of supervised learning algorithms there. Today we're going to see only one. Yeah. So as of super learning algorithm. So now algorithm that learns from the labeled training data to help you to predict outcomes for unforgotten data, unforeseen data. So as of you have to train the data based on the training. It may say later labeled on something. Moreover, it always uses the training. Sorry, it always uses the training data sets to achieve desired results. Use. Remember, so here the dataset contain inputs and the correct output that helps the model to learn fast. Today's session we are going to see the problem statement and how we are going to apply native Bayes and so on. Before that, we have to see about some example, general real-time example for understanding these super learning machine algorithms that called here. Let's assume that you have example of input that is the uh, what you can say means let's say the scenario. So this is the one we are going to check with the help of supervised learning algorithm. That means predict the time when you reach the home depends on let's assume that you are driving the car and you have to reach the home based on the situation like weather conditions, time of day, holidays, and route chosen. So everything predicted with the help of the supervised learning algorithms. Then there are many supervised learning algorithms. One is called nearest neighbor, another called native Bayes, another called descent trees, another called linear regression, another called support vector machine, at last neural networks. So now we are going to discuss about the new nearest neighbor. So nearest native Bayes, sorry, we are going to discuss about native Bayes only. So native Bayes means you remember it's come from the Bayes theorem and it has a formula like P of A by B is equal to P of B by A. Outside then P of A by P of B, where first one stands for the conditional probability of A given B, P of B by A stands conditional probability of A given B, and P of A is equal to probability of even A. At last P of B is represent probability of even A and so on. So this is a native Bayes theorem. We have to applicable. It's applicable for any. We have to use and it applicable for any problem statement. So let's go for a native Bayes understanding with machine learning. So as of supervised learning has two categories. One is called classification and another called regression. So when you doubt, please kindly check the playlist where it already we discuss about what is classification, what is regression, and so on. Here, general native Bayes algorithm falls under the category of classification only. Moreover, understanding native Bayes classification based on the Bayes theorem only, we can carry out the task here and also even A and even B. Let's go for the problem statement. So when before that we had no where is native Bayes used today. Let's say a lot of examples. One is called face recognition, another called weather prediction, another called medical diagnosis. Face recognition, like you can say, it also work as a classifier and more used to identify the faces or its other features like nose, mouth is especially Corona season, Corona time. We start to use the face recognition only. And weather prediction, as of it used to predict if the weather will be good or bad based on that one. And medical illness, here the doctors can diagnose patient by using the information that the classifier provides, and also with the help of Dickens, they can analyze whether the patient in the high risk or not like that. Then go for stopping example. So this is a problem we are going to solve now. Let's assume that the problem statement consists like predict whether a person will purchase a product on a specific combination of day, discount, and free delivery using a native Bayes classifier. So let's we have a diagram like day, discount, free delivery. As of here 7 days and weekdays and weekend holiday discount available are yes or not. Then probabilities. Yes means buy, no means think and buy and don't buy. So as of today many of the shopkeepers having the discount facility and many of the customers also like to purchase a product with discount only. And we're expecting when will whether we go market and fulfill and what are things we want on Sunday like that holidays like planning. Here, let's assume that we are going to have the free delivery based on the information. As of now, if the purchase something more than some amount, the shop shopping people have to the people have to give the home delivery. It may have more than 5,000 or 10,000 like that. So we have to say, just assume that a small data set have customer ID, name, last name, birth name, phone number, address, city, state, and points, everything. So as of if you go the real time one particular shopping mall frequently, the data is generated from them, and you will get the notification also. Nowadays, I think hope that everyone have a on mobile everything, so they get a SMS, everything you get it in offer is there like. And then based on the dataset containing three inputs there, one is called day, discount, and free delivery. So here frequency, we made one table here where consists of a frequency yes 19 by 1 no, no means 1, discount no means 5, like that is there. And here we have a by regarding free delivery, regarding the day, weekend, and these are the data based on the customer satisfaction, whether saying yes or not. Then go for a base diagram. Let even by be a even, and independent another variables like discount, free delivery are a b. Remember, so by is the a even, and the remaining where discount free are the b here. So let's assume that we have generated the table here based on the data where is highlighted points here. Okay, yes means what, no means what, and free delivery. So many majority people like the free delivery. Yes, buy, ready to buy. Discount means yes, many of them ready to, no means no, only few members ready. Even day, they are specialing weekday and weekend and holiday. So holiday, many of them not interested. Based on the data only, we generate the frequency table here. And here, let's calculate the likelihood of the one of the day variables. That means which includes weekday, weekend, and holiday variable. So it's based on the day variable. So like that, you can generate the data. So just now told you we are applying the formula also. And here, let's say that we get here 11 days, 11 weekdays, 8 weekends, 11 holidays. So let's assume that you are going to create the general data set. So there are 9 out of 24 purchases on weekdays and 7 out of 24 purchases weekends and so on. And here, based on the probability, what it means, we can conclude P of B is equal to P of weekday, and carry out the formula. So that is 11 by 30. So just now we told 11 weekdays. So we are going to take 11 by 30, it become 0.30, 0.37. Then we are going to P of A, that is no by. So as you see in the table, just now in the table you can look out here. So no, like that here we can predict here. So here totally 6 like that given likelihood table. So we are concluding here, that is 6 by 30, that's 0.2, and P of B by A is equal to P of weekday by no by. So it becomes 2 by 6, that is 0.33. The probability of purchasing that weekday is 11 by 30, or you can say 0.37. So as of Bayes theorem is we have to apply the formula only. Then it means that what, 30 people who are come in the store throughout the weekend and like and so on, 11 of them purchase were in the weekdays. So 30 people came, out of 30, 11 members only start to have interest and start to purchase everything here. So finally look out the probability P when no purchase occurs. So keep on going for the database here, and you have the frequency tables, all three dependent variables. That is what I told you, discount, home delivery, and so on. So let's go for another, generate the table here. So one is for with the day likelihood table and frequency discount. One is for frequency table with discount, and here free delivery, yes or no. So we are generating the database like this. So yes, out of 24, 9 members ready. No means 2 members ready. Out of 6, 2 members ready, and they have some probability table here. So based on that, we are going to predict and make the conclusion. So here, so as of you know, the whether customer will purchase a product or a specific company someday when there is a discount, and whether there is a free delivery. So they will think combination of the factors where B equals like day holiday, discount yes, free delivery yes. So the people like that on holiday they go and they will expect a discount and free delivery. All the options there, the customer happily go and purchase the product there. So let us find the probability of them not purchasing based on the condition above. So let's assume that the people not going the holiday, not willing to go, and discount not willing, and free delivery not willing. So that means A no purchase. That means applying Bayes theorem, we get the P of A by B like this only. That means like that we get some data. That means we are giving the application delivery and so on. It become 0.17 178. Similarly, let's find the probability of them purchasing a product under the conditions above. That means A is equal to by applying Bayes theorem. So before we see, no, not interested by now, we same concept. Just now I told you here, same. They're willing on holidays and they're willing to purchase a day discount and free delivery also. So once go for predict, you will like this come. Yes, discount yes, free delivery yes, and holiday yes, everything is giving. At last we'll get the calculation is 19 by 24, 21 by 24, 8 by 24, multiplies 24, 25, and here also 20 by 30, multiplies 23 by 30, and 11 by 30, it become 0.986. First here not willing, here willing. Here we'll get from the two calculations above, we find that probability of purchase is what? Highlighted 0.9 and here 0.17 something. So we have a conditional probability. That means what? Sum of probability is what? This we are going to add. This two we are at add, it become 1.10. And also likelihood of purchase also 0.996 by 1.116 that we got here. That become 84.71 percentage. At last likelihood of the no purchase 0.178 by 1.1164. Just now got it. So it become 15.29. So at last we conclude the result for the shopping statement problem. That is the result is 84.7% is greater than 15 point. So as I compared here, this is big high greater than. So we can conclude that average customer will buy on holiday with a discount and free delivery. So you can predict why you go for this negative base means it become easy. Whatever whether you have discrete data or continuous data, we can go for the native base. Moreover, accuracy also. When you go for this theorem, the native base theorem, you get the accuracy and training data. If you go for this one, we no need to go complete training of data. Some data you can give training. After that, you can start to predict everything. I hope that you understand about native base theorem. Remaining will continue in the next session. Thank you for watching the video. Please subscribe and share with your friends. Thank you.